Okay, this is lecture number 12, and it's entitled as Structure of Chaos. So what I mean by structure, what I mean by this term structure. So we have, let's consider logistic map when our parameter R is 4 times UN 1 minus UN. And we know that in this map, if value of U0 is irrational number, so U0 should be in the domain 0 to 1. If it's irrational, then we will have chaotic solution. And what the question here is, how likely to have different values of U for large enough n, let's say, consider Un where n is large. Then how likely for Un to have various values? So we know that it can have basically any value, but what we want to know whether some values are met more often than others when n is increasing. So n is increasing. So this we know that. So to do this, we consider Un. Consider Un as a random variable. And the random variables, continuous random variable, it should be described by probability density function. Density function, so we can call it P of U. So P of U, by definition, I just remind you definition, it's from mass 162. You all had it. Probability that Un is between value U and U plus, say, du. So probability for Un to be in this segment is equal to probability density function at U times du. So this is definition of probability density function. So we have plot of logistic map Un plus 1 with roots root 1 and maximum at half. Maximum equals to 1 and R is 4. So now if this is value of Un, then value of Un plus 1 is this. And what we consider how likely for Un, so for Un and Un plus 1 to have certain values. To find probability density function P of U, we will first find probability density function for theta, for theta, variable theta, and theta is what we introduced in the previous lecture, where U was sine squared pi theta. So we know that in terms of theta, logistic map transfers into theta n plus 1 equals to 2 times theta n, when theta n is between 0 and half, and 2 theta n minus 1 if theta n is between half and 1. And we know that all values of theta n are equally likely. We've seen it last time because theta n indeed, so a number which can have any binary representation, and this would mean that it could be any number between 0 and 1. And therefore, probability density function for theta is some kind of constant. And this constant is easy to find because probability density function of theta d theta. So theta can have any value from 0 to 1, and this is constant times d theta from 0 to 1, and we know that total probability should be equal to 1. And at one hand, on the other hand, it is c. Therefore, we got c equals to 1. Well, to find out p of u, let's consider this function u equals to sine squared by theta. Let's plot it. So this is theta, this is u. It's again, so this is sine squared, it's positive function, it is 0 at 0 and 0 at 1. And again, so maximum is again 1. So it looks like very much like logistic map itself. Now, we know, so this is theta, and this is d theta. So this segment of size d theta. So probability for theta to have a value in this range is p is c times d, well, yeah, p of u, p of theta times d theta, which is just d theta, because is p of theta d theta, but p of theta, we know it is 1, it is 1 times d theta, which is d theta. And what is it? So this will be probability for u to be in this range. P of u du will be equal to d theta. The only point is here to mention that in u in this range will be for when theta is in this domain, and also when theta is in this domain. So let's say I will put it theta 1, and this is theta 2. And here it will be again d theta. So therefore, this probability for you to have value u, and between u and u plus du, it will be d theta plus d theta. So it is 2 times d theta. And therefore, p of u is 2 times d theta over du. We can put it like this, 2 times du over d theta. And du over d theta we can find from here. Du over d theta is 2 sine pi theta times cosine pi theta times pi. And this two sign, this we can keep it like this. Therefore, probability density function of u is 2 over 2 times sine pi theta cosine pi theta and times pi. So 2 cancels. Will be 1 over pi. Sine pi theta is square root of u, because u is sine square, therefore sine is square root of u. And cosine pi theta is square root of 1 minus sine squared pi theta. And sine squared pi theta is u, therefore it will be 1 minus square root of 1 minus u. And therefore we will have here square root of u times square root of 1 minus u. And this is 1 over pi times square root of u times 1 minus u. Again, probability density function of u, 1 over pi times square root of u times 1 minus u. Let's check how it looks like this. Probability density function. This is u, this is probability density function of u. Now u changes between 0 and 1. So probability density function is infinite when u is 0. It's infinite when u is 1. And it has minimum in between. So since it's symmetric, minimum will be at half. And from here we conclude the following. What we see is that probability for u to have values near 0 and 1 is considerably larger than probability for u to have value around half. un is more likely to have values between around 0 and 1 and less likely about 0, about half, sorry.